After this problem involves the height and velocity. The height of a cannonball in meters is given by 120 t minus 4.9 t squared, where t is in seconds. A passing in unfortunate bird gets in the way of the cannonball 710 meters above the ground. Find the possible velocities of the cannonball at impact. It says, to get started in a problem like this, I recommend doing the derivatives first, and then we will deal with the word problem aspects second. So first we have the original position, and then if I take the derivative with respect to time, I get 120 minus 9.8 t. And so that is the velocity. Okay, a passing bird gets in the way of the cannonball at 710 meters above the ground. So that suggests that we solve S of t is equal to 710 for t. We set the height equal to 710, and we figure out the time at which this happens. So 120t minus 4.9 t squared is equal to 710. And so we can get everything over to the right-hand side. We get that 0 is equal to 4.9 t squared minus 120t plus 710. All right, that is a fairly nasty quadratic equation, but we have the quadratic formula. So t is equal to negative b, 120, plus or minus the square root of b squared, 120 squared, minus 4 times 4.9 times 710, all divided by 2a, which is, so I'll just do that 2 times 4.9. Okay, now if we do the arithmetic, we get 120 plus or minus the square root of 484 divided by 9.8. And this actually works out even. It works out to be 120 plus or minus 22 divided by 9.8. Okay, so if I subtract 22, I would get 98 divided by 9.8. And so one option would be 10 seconds. The second option doesn't quite work out so simply. 120 plus 22 is 142 divided by 9.8. Okay, now we'll leave it like that for the moment. Okay, now the question asks, find the possible velocities at impact. And so part 3 of the problem will be find the velocity at these times. Okay, and we recall that the velocity function was 120 minus 9.8 t. We did that earlier in the problem. And so option 1 at time 10, we would have 120 minus 9.8 times 10. And so that was 120 minus 98, and that works out to be 22 feet per second. So it could be going upward at 22 feet per second. The other option, I plug in 142 divided by 9.8. So that's going to be 120 minus 9.8 divided by, or times 142 divided by 9.8. And the 9.8s will cancel, and we get 120 minus 142. And so the other option would be negative 22 feet per second. Okay, so this one, the cannonball would be going upward at 22 feet per second. For this one, the cannonball would be going downward, falling at 22 feet per second. So 10 seconds, it hasn't quite reached the peak. At this time, it has gone past its peak and is now falling downward. Those are the two possible velocities when the cannonball strikes the bird.